Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over section 9.1 on our virtual algebra 1 series on quadratics. We're going to be looking at how to factor quadratic expressions of the form x squared plus bx plus c. This standard is covered in Algebra 1, Algebra 2, and Pre-Calculus courses. Don't forget there are 5 practice problems at the end of this presentation that we'll like you to try out in order to demonstrate mastery of what we covered in this video presentation. If you'd like to gain access to an entire playlist or other valuable resources, take a look at the link in the description below, or you can just visit our website at mathgotserved.com. Alright, so the instructions for the example that we're working on is as follows. We have to factor the given expressions completely. Okay. Number one, let's say we have the quadratic trinomial v squared plus 6v minus 40. Okay, so let's go ahead and factor that. Now, anytime you're asked to factor any kind of expression, the first thing you want to ask yourself is there a greatest common factor that I can factor out from the given expression? Okay, so is there a greatest common factor that I can factor out here? Obviously, there's no greatest common factor that can be pulled out, but to make it explicit, what I'm going to do is go ahead and break down each of the terms, and then let's look at them and make sure that there are no common factors that can be factored out. If you break down v squared, you end up with v times v. If you break down 6v, is 2 times 3 times v. If you break down 40, is 2 times 2, basically using the factor tree. So 2 times 2 is 4. And then 4 times 2 is 8 times 5. So if you take a look at these three terms right here, what you notice is that they have nothing in common. Okay? All right, so let's multiply them back together. We have v squared plus 6v minus 40. Now what we need is we need 4 terms. Okay, we need to convert these 3 terms into 4 terms in order to factor by grouping. So in order for us to figure out what we can replace the middle term with, we're going to play the x game. Okay. All right. So for the x game, A, C will go on top, and B will go on the bottom. Alrighty. So there's a 1 here, and then we have A is 1, B is 6, and C is negative 40. So AC is 1 times negative 40, which is negative 40, and B is 6. Okay, so we're going to play the game. What two numbers multiply to give you negative 40 and add to give you 6? Well, if you can't think about it off the top of your head, you can just make a multiplication grid. Find all the pair of numbers that multiply to give you 40, and then add or subtract them and see which one gives you 6. Okay, so we have 1 times 40, we have 2 times 20, 3 doesn't go, 4 goes 10 times, 5 goes into 48 times, 6, 7, nope, and we're done. Okay, so let's look at the pairs here. Do you see any pair that adds or subtracts to give you 6? The first one gives us 41 or 39. The second one gives us 22 or 18. The next one gives us 14 or 6. This one gives us 13 or 3. So let's go back here. This one gives us 6. Oh, voila. That's exactly what we're looking for here. So a combination of 4 and 10. Okay? So we're going to place our 4 here and then the 10. And let's look at the signs. We need to make sure that the signs work. In order for the combination to be positive and for the product to be negative, the smaller of the two has to be negative. Okay? So in this particular case, we have a scenario where A is equal to 1. So whenever A is equal to 1, you can skip grouping. Okay? We can skip grouping and head right to the completely factored state. So we're going to have V with times the first, combined with the first quantity, V minus 4 times v plus 10. Okay, and that, ladies and gentlemen, is the answer to question number 1. All right, let's take a look at the second one, number 2. So for question number 2, what if we're to factor the quadratic trinomial n squared plus 7n plus 10? Okay, so this particular problem will be very similar to what we just did in number 1. So what's the first question we want to ask ourselves based on our conversation in question 1? We want to ask ourselves the question, is there a greatest common factor that I can pull out of the original problem? So do you see a GCF that you can pull out from n squared plus 7n plus 10? Do you see a GCF that you can pull out? Well, let's break it down to know for sure. So the first one breaks down into n times n, the first term. The second term is 7 times n. And the last term is 2 times 5. Now, do you see a common factor in all three terms? There are no common factors, okay? So there's no GCF to pull out. So we're going to multiply them back together, n squared plus 7n plus 10. All right, so in order to factor this, we need 4 terms, alrighty? So we're going to play the x game again to see the 2 terms that will enable us to factor this quadratic trinomial. So AC will go on the top, and then B will go on the bottom. N squared doesn't have any coefficient, so it has an invisible coefficient, which is 1. So we have A, B, C. Okay, now AC is 10, and then B is 7. So now we're going to play the x game. What 2 numbers multiply to give you 10 and add to give you 7? All right, so let's exhaust the pair of integers that multiply to give us 10. See if we can figure out the answer. 1 times 10 is 10, and then 2 times 5. And that's basically it. Okay. All right, so the first pair gives us 11 or 9. No good. The second term gives us 3 or 7. Voila. So we're looking at 2 and 5. That's the pair that we're looking for to make the x game work. So if you check it out, you have 2 times 5 is 10. 2 plus 5 is 7. Now, one thing you want to note in this problem is that A is equal to what? Whenever A is 1, you can always skip grouping and jump directly to your factored state. Okay, so we're just going to combine n with these two. So n plus 2 times n plus 5. That's the answer to question number 2. Alrighty, let's take a look at question number 3. Okay, so for question 3, what if we were to factor the quadratic binomial n squared plus 4n? Alright, so let's go ahead and factor this. So whenever you're factoring any quadratic or polynomial expression in general, the first question you always want to ask yourself is there a GCF that can be factored out? Okay, so let's see here. To know if there's a GCF that can be factored out, we're going to break down both terms, okay? So break down the first term, n times n. We break down the second term, 2 times 2 times n. Is there anything common? Absolutely, we have an n and an n that's common to both sides. So you factor that out, okay? So when you factor it out, it's as though you're dividing it out. So factor it out and divide it out. 1, 1. And then you're left with n plus 4. Okay? So since you have a first degree, a linear binomial, and a monomial outside, this is the simplest form that you can factor this expression. Okay? Remember, the x game is used mainly for factoring trinomials, and this is a binomial situation here. And then another thing to know, the x game is meant for quadratic trinomials. You can also use the x game for quadratic binomials, but in this particular case, since You have a linear to degrees 1. That's the simplest form. You cannot factor it any further because we took out the GCF. So the answer is n times the quantity n plus 4. All right, let's try one more example. Let's say we have the quadratic trinomial x squared plus 3x minus 18. We want to factor this completely. Okay, so what we're going to do is first of all ask ourselves, is there a greatest common factor that can be pulled out? To answer that question, we have to decompose each term. So the first term breaks down to x times x, the second term 3 times x, third term 2 times 3 times 3. Okay, you can use the factor tree to do this. So that's the decomposed form. Now, is there a common factor? Is there a common factor in all three terms? The answer is no. So we multiply it back together. X squared plus 3x minus 18. Now, since we're factoring a quadratic trinomial, we need 4 terms so we can factor by groupings. So we are going to use the x game to help us with that. So let's go ahead and play the x game. Okay, so the coefficient of x squared is 1. So let's specify a, b, c. So this is a, b, and c. So in this particular problem, AC is negative 18 and b is 3. So what two numbers multiply to give you the top and add to give you the bottom? Well, let's see. We're going to list all the pair of integers that multiply to give us 18 and then see which one combines to give us 3. Alrighty, let's do it. So we know 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. And 4 and 5 do not go into 18, so we have a full loop. And here we have. So which pair basically work here? 1 and 18 gives us 19 and 17, no good. 2 and 9 gives us 11 and 7, no good. 3 and 6 gives us 9 and 3. Voila, that's what we're looking for. A combination of 3 and 6. So we're going to put it in here, 3 and 6, and work with the sign, okay? So we notice that the sum is positive, but the product is negative, so that means that the smaller has to be negative. Alrighty. Now, since A is what? What is A in this case? A is 1. Guess what? We can skip grouping, the grouping step. That's the beauty of factoring quadratic trinomials where A is 1 because we can take shortcuts here. So we can skip grouping and jump to the factored state, which is x, and then take the first factor, negative 3. So x minus 3 times x plus 6, and that is the answer to question number 4. X minus 3 times x plus 6. Now, just a side point to keep in mind for this problem before we do the practice problems is that you have to remember that multiplication commutes. Well, what does that mean? It means that you can write the answer like this, or you can also switch the factors, the order of the factors. You can also write it as x plus 6 times x minus 3. Okay, it doesn't matter how you write it, since as long as the quantities in the parentheses are identical, and since multiplication commutes, it doesn't matter how you write the order of the factors. There goes the answer to question number 4. All right, it's now time for you to demonstrate mastery. We'd like you to try out these 5 practice problems. The instructions are for you to factor completely. So what we'd like you to do is go ahead and pause this video presentation at this time. Factor these 5 problems completely. When you're done, click on the play button in order to see what the answers are. All right, welcome back. Hopefully you had a chance to try out the practice problems. Let's take a look at what the solutions to the problems are. For number 1, the factored state is p plus 4 times p plus 3. Of course, you can write it as p plus 3 times p plus 4. Number 2 is n plus 5 times n minus 10. Number 3 The factored state is r plus 9 times r minus 8. For number 4, the factored state is r minus 10 times r plus 2. And then for the last one, it's x times x plus 9. Alrighty, so how well did you do with these 5 practice problems? Let us know in the comment section below how well you did. If you have any questions or need clarification on any of these problems, just specify what your needs are in the comment section below and we'll be glad to assist. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of factorization, to give us a thumbs up or like. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this tutorial or any math concepts in general, just post it in the comment section below and we'll try to respond. Do not forget to subscribe to our channel. We upload videos to our page on a regular basis. And if you like access to a wide variety of support resources, take a look at the link in the description below or just visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.